Happy Friday. How are you guys?
Good. Did you enjoy yesterday? You had a
Oh,
busy day yesterday.
oh, it was horrible. I had to talk to John Force and Tony Stewart. That was terrible. And Matt Hartford. What a day we had. And then the surprise of Linda Vaughn at the end of it. I walked away, obviously, for those that don't get American sarcasm. That's a joke. I had a great time. And I walked out of the studio and I thought, my goodness, like, could I have interviewed four bigger personalities back to back than that? I don't think so. The stories Linda was telling, and I know you guys at EPARTRADE, you will put these out on your own channels throughout the year. But what a treat. What a treat. Hopefully the audience enjoyed it. We're going to have more fun today. I know we've got Top Fuel World Champion Doug Coletta later on in the day. I just interviewed him on my WFO radio podcast a couple of weeks ago, and he is just so excited about this championship. Jim Oberhofer, we're going to talk crew chiefing, but right now we're going to dive into it with a couple of friends as well from the AERA, the Automotive Engine Rebuilders Association. Speaking of the next generation, this is what these guys are doing. They are like providing a pathway for the next generation of engine builders and machinists. So I'm super excited to get started.
We're proud to have both Chuck and Brian on. Thank you.
Excellent.
Good to see you guys.
Judy, thank you so much. What's up, Chuck and Brian? How are you guys? Good morning, good day, good afternoon.
Good morning. We're doing great. How about yourself, Joe?
Oh, super excited. What a year it has been. And EPARTRADE Industry Week has become part of the conclusion of the year, or maybe the start of next year. Not quite sure. But let's talk a little bit about the AERA at the start of 23. I was honored to have been able to witness one of your regional events and see a packed house at Randy Neal's shop. We're talking balancing, talking engine rebuilding, just a live in-person seminar. And what was what stuck out in my mind was all the youth there. I know you guys provide a guidelines and have all the data to every engine pretty much built from the dawn of man, but you had a really good following with students, frankly.
Yeah, absolutely. We have an engine machinist certification program that we've over 70 schools participate in. So yeah, that's been a really good program for us. And, the continuing education stuff. So like today, you got Brian here on board. Brian's got a lot of history in the gasket manufacturing, many years with Felpro. He worked for Dana, Victor Rhines, Modern Silicone. So you being at the track all the time, know how important that gasket design stuff is and keep stuff sealed up. So yeah, I guess we'll kind of let Brian get into rolling out some of the gasket features. He's got some slides to share, and on kind of MLS gasket design, we're going to kind of keep it focused on that. You talk all gaskets, we don't have enough time in a couple days. So anyway, we'll let him roll into that just a little bit, and then we'll talk about surface finishes and machining and the importance of those factors with gasket seal.
Excellent. Brian, take it away.
All right. Thank you. Let's see if I can share this screen here. All right. Everybody see that?
I do. Yeah, I got it. Chuck, you see it?
Oh, yeah. Good.
Okay, good. Just make sure everybody can see it. Okay, so we're going to focus primarily on MLS. It seems to be the dominant technology used today on most current engines. So if you look at MLS construction, it usually consists of multiple layers. The outer layers, which we refer to in the industry as active layers, they have a rubber coating. So if you see the blue, that's the rubber that's applied to both surfaces of, generally it's like a full hard stainless steel of some kind that has memory. And then it's embossed with, tooling in a punch press or hydraulic press. And those embossments are formed into that stainless steel, and it forms basically a hump that once you compress it, it concentrates the load in that area for the seal, And then as the head lifts during the combustion process, it acts like a spring and travels with the head and maintains contact on the flanges to maintain the seal. In the middle there, you see the distance layer. That's usually just a shim layer of a given thickness that is put in the middle just to give it the correct thickness that's needed. In the aftermarket conditions, obviously you'd want to have a thicker than OE head gasket to allow you to machine the surfaces of the block and the cylinder head and return the height back to what it was or close to it. So when you look at, let's see, can you see my mouse floating around here?
Yes.
Yes.
Okay. All right. So these embossments right here on these two layers here, if you picture the cylinder head being torqued up, these two layers would sandwich together and make contact with that distance layer. And then as the head lifts, they return back up like a springing action. So it maintains that seal. And what's important on this rubber coating is the ability for it to seal all of the micro surface finish conditions that you encounter in machining. And the surface finish down below is like an exaggeration, obviously, but these little peaks and valleys in here embed into this rubber coating and provide the micro seal for fluids. So that's critical that you have the correct surface finish for this particular application of MLS. So, and if you look at this slide, this is a hyper exaggeration as well of it sitting there, and you can see on the far right hand side where the valleys are. I hope you can see it at least. The valleys, there's voids there where the rubber is not thick enough to accommodate that surface finish, and that's a potential leak path for fluid. So again, that surface finish is critical. We're going to get into that, but just so you understand, that's what that coating is for, and that's why it's very important to assemble in a clean environment, because it's very easy on some of these MLS head gaskets to take it out of the package, set it down on your workbench, and any shavings or whatever that might be there, dirt, debris, can sometimes stick to that surface of that rubber coating. And if you're not paying attention, you'll put that onto the cylinder head and the block. And when you torque it up, you damage the gasket or the flange. So you got to be careful of that.
Yeah, good point. With the cold seal materials that are applied sometimes can be sticky, so they can pick up cardboard dust, they can pick up any debris that might be in your shop. So clean, cleanliness next to godliness, we always say that. But if you have a sticky material that's applied to the gasket, then you can set yourself up with trouble right out the gate just because of that. Hey, Brian, if you could go back to that first slide, maybe we could
Sure.
talk a little bit about like the chamfer of a cylinder bore. You got to be
Oh, yeah, good
cautious
point.
that if you squeeze down on those active layers and that leg can't react because it's falling into a chamfer of the cylinder bore, then you're going to also have a hard time maintaining a combustion seal over the long duration, because that's going to flutter.
Right. So like Chuck was saying, let's just pretend that this edge here is the combustion opening side of the gasket. When this thing is installed, if somebody gets real aggressive, let's say it's a tight fit for the cylinder bore to the gasket bore, and somebody gets really aggressive on the chamfering, that chamfer could be underneath a portion of this MLS gasket, so it's hanging out there. On some designs, they'll have a stopper that's on the distance layer, and that's just like a primary seal, and then this seal back here acts as the secondary seal, and then that stopper helps with head bore distortion, head bending, stuff like that. But if that is hanging over into that unsupported chamfer area, you can almost have a hot spot condition on that edge or more likely you're going to have that flutter going on. And as you're getting cycle after cycle after cycle, basically it's like taking a paper clip and bending it back and forth, back and forth, back and forth. Eventually you have metal fatigue, and then you have a crack and it breaks. So we've seen it where people get pretty aggressive on those chamfers to help with installing the piston rings, but you got to be careful and make sure that you don't go too far on that. Pay attention to where that gasket is landing. So.
All right, and I think we can now kind of get into the surface finish and flatness information that you got there. So,
sure. So we got some general guidelines. Most of this information, was provided by aftermarket suppliers like Felpro or Victor Reinz. But these are generalizations. So 3-cylinder V6 engines, the max out of flat condition across the length of the cylinder head, 3 thousandths width. I think it was 2. I can't see here with stuff.
yeah,
yeah. 4-cylinder and V8 engines, 4 thousandths. Inline 6-cylinder engines, 6 thousandths. So
basically a thou per bore length.
Yeah. So just want to pay attention to that and make sure that you're not exceeding that, because you can have the correct surface finish, but if it's not flat, you're still going to have issues with the head gasket. So make sure you got the right surface finish and it's flat is going to give that gasket the best chance for success. Do you want to get into this portion of it, Chuck?
Yeah, sure. So, Brian saying surface finish, surface roughness, RA is a really old spec. It actually doesn't give us a ton of information. More currently, we're looking at specs like RZ, where you get a lot more data out of that trace sample, and then waviness. And with MLS gaskets, we just can't speak to flatness enough. So we mean flatness, yeah, you check with a straight edge and a feeler gauge or whatever, but there's also the waviness effect. Waviness and roughness are 2 totally different things. So roughness is kind of the grip, but waviness is kind of like the topography of the whole surface. So if you were looking at the ocean, peak to valley waves or something like that, or the mountains around us. So the little rocky crags and so forth that you're going up and down a mountain, and where the little stones, that can be kind of your roughness. But from the peak to the valley is super important as well. So if you take a look at when we set up our machines, sometimes if we don't have a good rigid setup, the machine's not on a good footing or whatever, we can induce waviness, and that is totally different than the roughness. The thing is, the frequency at which that waviness exists is really important. So if you you have a situation of like a vibration, it may be at a high frequency that, like in that one image that Brian showed earlier, where there was a gap under the cold seal. Well, you can imagine that on the rigid part of it, that those are at a frequency that steel gasket can't conform to that, kind of like the suspension bridge thing. You see a sag in it, but it doesn't reach the bottom. Well, ideally it's a bridge, you don't want to. But when you're trying to seal a surface with a gasket, you don't want those valleys below the bridge. You want full contact, and give every opportunity for that thing to seal for a long time. And now with forced induction on just about everything, we really need a better method of measuring in the shop to make sure that we are flat. And there are waving or profilometers that measure waviness, but it's just become so critical because MLS gaskets are everywhere.
Yeah, I agree. Shops, they just have to have a profilometer. You just can't use like a old school comparator or fingernail, method. You just don't really know what you're dealing with as far as the surface finish. It may look good, but it could be a problem.
Yeah, I get, especially like some of the OE cold seal technology is different than the aftermarket. The aftermarkets are looking at, hey, not every surface is getting the attention, So say somebody takes a head to a machine shop, but they don't do something with the block, and the aftermarket's trying to accommodate that. But there's limits to everything, right?
Yeah. Yeah, when we're talking surface finish, we're not just talking the cylinder head. The block needs to be taken into account as well. Sometimes that gets overlooked, but. All right. Do you want to continue on, Chuck, or do you want me to do this?
Yeah. We can kind of tag team it here, but heads, blocks, manifolds. I think sometimes we probably don't give the exhaust face or the intake face the consideration, but most of the time those are going to be a very hard gasket, so they're going to have to be really smooth and flat. Any comments on that, Brian?
Yeah, a lot of the modern engines these days are using like an MLS exhaust manifold gasket. Some intakes, usually I think on the intakes, it's maybe like a single layer, like on some Toyotas and stuff. They use single layer rubber coated metal. So it's basically one layer of an MLS gasket, basically. And, the surface finishes still apply.
Right. Actually, you would think, okay, so I don't have that reactionary effect of the spring. So that means I need to be smooth and flat, probably more so than the other components. But
yeah. Smooth is good, but getting too smooth can also be an issue where it doesn't bite into the gasket and the gasket can move around. And gaskets moving is not a good thing. It will destroy the gasket over time. So,
yeah, to go back in history a little bit, I think, that's probably what drove MLS gaskets, right? So when you had, say, an iron block aluminum head, you had a different thermal expansion rate of those two surfaces. So we did things where we would lace the gasket on the aluminum head side because we know that it moved more. We were a little bit smoother, but we had a fairly aggressive surface on the block to grip that gasket. And you still had gasket shredding, false Brinelling, things of that nature. But with the MLS gaskets, not only do you allow head lift, but some lateral movements when you stack those pieces together. Now, I think as a rule, the more layers in the gasket is probably because testing proved that there was more movement, right?
Yeah. When you see five, like MLS head gaskets that have, 4, maybe 5, sometimes 6 layers, that's to accommodate massive amounts of head lift. So finite element analysis testing, and then real world measurements, in a lab environment shows that when that engine cycles, the head is lifting X amount of distance. And then that distance to accommodate, contact between the flanges consistently, you add more layers. One of the common ones I can think of is like the Ford 6.0 diesel. That guy had a lot of head lift. So
a lot of head lift and not a lot of bolts, like right?
Layers or something. Yeah. So,
yeah.
Yep.
So some of the coatings, could you speak to that a little bit?
Sure.
Are they mostly silicon based or silicone based?
I don't think I've run across any manufacturers using silicone.
Okay.
Traditionally, it's usually like a nitrile or a Viton or FKM type of coating. Obviously, the FKM Viton has a higher temperature range, so it's also quite a bit more expensive. So it's used selectively for applications that absolutely require it, where nitrile primarily covers the vast majority of MLS applications out there.
So just to, so people would understand, those are also the things that you would see running against a crankshaft or a valve stem seal or, something of that nature. So Viton's a trademark.
Fluoroelastomer, FKM, you might have heard all of those terms, but that is utilized a lot in specialty applications. Nitrile is probably the vast majority of applications out there. So I don't think I've ever seen silicone.
Yeah, I was just throwing it out there just as a reference
okay.
point or something. Yeah.
Yeah, silicone's
you know-
operating temperature ranges. I don't know if that would be adequate. So, and then it's tensile strength. So, yeah, stay away from that one, I guess, for now. I don't have any background with that. So, so if you look at some of these, like RA finish, RZ finish here, like you see that 80 RA, that's on aftermarket head gaskets. You can use an most aftermarket head gaskets up to like an 80 RA. But if you have a OE head gaskets, usually you want to be in that 30 RA range to accommodate it. So the aftermarkets, they put in a little bit thicker coatings to handle those more aggressive surface finishes. But there is a limit that you can go to. So you got to stick within it.
You know, and Joe, this is some of the same type of information that we have in our machinist certification program manual as well. So, you know, anything from shop safety to handling, you know, materials, chemicals, standard processes for machining, you know, chip load, you know, what is climb milling, you know, just that kind of jargon. So general machine shop, and then translate that into automotive machine shop, and then part design and so forth. So yeah, going back to the continuing education thing, this is just a bit of what we try to do at AERA. We're not just a source for specifications, but also training education for the industry.
Yeah. All the young guys coming in, make sure that they are skilled and know how to do this stuff.
And on that note, there is a question in the chat. I just want to mention it. But before we get to that, because, you know, the seminars are a little quicker this year, give all the vital information where people who are watching and realizing that this is vital and important, but want to find out more or reach out to you guys or maybe even join the AERA. How does all that happen?
So if you want to just check us out, the short answer there is you could go to AERA.org to our homepage, and then there's tons of tabs. There's technical, there's history, there are outreach programs. We got the Engine Rebuilders Education Foundation, links to our magazine. We have the Engine Professional magazine, links to get signed up for the courses if you would be interested in doing that. Of course, you know, feel free, you could call AERA directly. We have a tech line that you know, direct for membership, for schools, whatever. And yeah, but if you just AERA.org is probably the best opportunity to take a look at all of that as a whole.
And the question from James is like, where is all this improvement coming from? And I think the answer is probably both, but if you could elaborate, is it better ability to manufacture, or is it measure? Like, are we manufacturing things better to increase the seal, or are we measuring better, or is it really just, as our great mutual friend Lake Speed says, a soup where it's all important?
I believe it's really that, because, you know, if you measure with a yardstick, what is your tolerance? So as we keep improving process, and then we have to measure more closely to see where you're at, you know, because ideally you try to make the, you know, spec fit the need, right? So there's like, does the window fit the spec, or the spec fit the window? So it's really about need. So as we keep increasing horsepower, is, you know, everything now is small displacement and it's forced induction, and we're using as much of the, you know, fuel efficiencies as we possibly can. So as we continue to do that, we keep tightening that tolerance. So I think it's kind of hand in hand. I need I need to be able to measure it accurately and measure the right thing. So I hope that answered that.
It absolutely did. And you guys are always wonderful. And frankly, having been able to see multiple of your presentations over the years, it's important. And if you're going to spend money, as everyone does, to build these engines, whether high performance or otherwise, you might as well get it right. Like Brian said about the gasket on the work table, picking up some debris and being conscientious and seeing and hearing the way you think, I think is extremely valuable to the person out there who's got a project, pursuing a project, or is in this business. Because you guys as industry leaders and the keeper of the scrolls, if you will, if that's how you think, that's how everybody should be thinking about it. So great job.
Thank you.
Well said,
Thank you.
Joe. And we wanted to give everyone a little preview of, this is what we do every week at EPARTRADE from beginning of February to the end of October. We run a weekly tech webinar series. Race Industry Week, as Judy says, every morning is the icing on the cake, where we bring all the big speakers and series organizers and promoters from around the world. But what you just saw from the AERA is a series called Race Industry Now that we produced every Wednesday on the EPARTRADE platform, and we invite all the suppliers in the industry to talk about technical subjects. So thank you very much, gentlemen.
Registering on EPARTRADE is easy. To start, click on the Join for Free button on the homepage. First, search your company to see if it's already in our database. If you see your company on the list, click on it to select it. Then, choose Claim Company if you are one of the decision makers, an owner, marketing person, or main company contact. Or choose Join Company if you are an employee, and press Continue. If you couldn't find your company in our database, select Register a New Company. On the following page, fill out your name, email, phone number, job title, and choose a secure password. If you chose Register a New Company, you'll need to choose your business type. Select Supplier if you're looking to display products or services and connect with buyers. Choose Racing Business if you're looking to source new parts and connect with suppliers. Choose Race Team if you own or are a member of a professional race team. Then, enter your company name. Please provide a website, Facebook page, or LinkedIn if you have one, and choose to either claim or join the company. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Finally, click Register Now and your registration will be submitted for approval. An email will be sent to your inbox. Please confirm your email address and you will be approved shortly. Welcome to EPARTRADE.